Hi there. This is Mr. Sand again, and we're going to talk about how to report your uncertainty when you're using calculations. So I've got this example right here of an area that you need to calculate. So report the area with correct uncertainty. So in this case, it looks like, ooh, sorry about that. It's kind of small. Let me zoom in a little bit. All right. So it's 10.19 meters plus or minus 0.05 meters. And this side, the length of this side is 12.3 plus or minus zero point 0.1 meters. This side was obviously measured with a digital device of some sort, and this side was measured with some analog device of some sort. So how to report this with our uncertainty? Well, first of all, we know how to find the area. At least you should. I really hope you do know how to do this. So it's 10.9 meters times 12.3 meters, first of all. So let's just calculate that. I've got my calculator here. So I'm going to just put that in. 10.19 times 12.3, and boom, I get 1.125.337. All right. I'm going to round this to this last. I'm going to. In this case, we haven't talked about sig figs yet, but I'm going to round. You'll see. I'm going to round right now to. This was not the best example. I'll just round to this number right here, 10 point or one. Sorry, 125.34. Let's just do that meters. So that's what I'll use as my area, and that's meters squared because it's area. We multiply meters together. So that's our area. So what do we do with our uncertainties? Well, you always add your uncertainties, no matter what. If it's division or if it's subtraction, any kind of calculation you use with your uncertainties, you simply add them together. So in this case, we're going to take 0.05 plus 0.1, and we're going to add those two together, and you're going to get 1.5 meters. Okay? Well, our units right here are just really in terms of meters, and so in this case we're using meters squared, so it's going to be 125.34 plus or minus 0.15 meters squared. So that's going to be our final answer for this problem right here. You just add the uncertainties. Even if you're multiplying here or subtracting here, you just simply add your uncertainties as if they're a separate kind of function outside of the normal number that you're using just to subtract or divide or multiply or add. You're always going to add your uncertainties together. And that should make sense to you because if you think about it, your uncertainties, they should add together as you're using more numbers. They should just continue to combine and increase. All right. So let's what should we do now? Let's talk about percentages in our uncertainties. So let me get a brand new sheet here. So percentages in our uncertainties. So let's say that we're just using these numbers. I'm going to use density. It's an easy thing to do. I think you've got an example of this in your homework as well, your workbook. So let's just say that let's do an easy problem, 5.1 grams, and let's say that you've got a volume of 3.31 milliliters. And your uncertainty here is plus or minus, let's say it's 0.1 grams, it's measured digitally, and this one it's plus or minus 0.01 milliliters. That's again measured digitally. So you'll know that it's 1 in the last estimated digit. In this case, it's there. In this case, it's in that place. So that's what we're going to be using. So how do you do this? Because they're different units, right? So the units of uncertainty here, they just can't simply add to those units. They're different units. This is grams that measures the mass of something, and this is measuring the volume of something with milliliters. So first of all, if we're measuring density, what you need to do is you need to divide these two things. So density is grams divided by milliliters. And if you didn't know that, that's okay. We're going to cover that shortly. But I'm just using this as an example to show division with different units here. So don't worry that you don't know that density is not grams over milliliters yet. That's not a big deal. What matters is that we've got different units here, and we have to change those units into something called a percentage. So first, we'll just take our main measurement here, and we'll take 5.1 grams and then divide it by 3.31 milliliters. And if we do that, we get this number right here, 5.1 divided by 3.31. And we get 1.5, we'll just round it to 1.54. This is 1.54 grams per milliliter. Okay, but we can't have grams over milliliters as our uncertainty. That looks a little weird. We can't have, and even if they try to add them together, it wouldn't really work because they're different units. This is measuring volume and that's measuring mass. So how do we do that? What do we do for that uncertainty? This is a problem. What we do is we change these uncertainties into a percentage of the measurement, and then we add the percentages. I'll say that again. We change, the first step is you change uncertainty into percentage. And then the second step is you add the percentages. You don't need to change this back into these terms over here, grams over milliliter. Add the percentages. Okay, so the first step, let's do the first step right now. Let's change this 0.1 grams into percentage. So how do we do that? I'm going to use a different color to show you that. So we're going to change this into a percentage. This is the green part. So here's how we do it. I'll put a little arrow over here. We take 0.1 grams, we take the uncertainty, and then we divide it by our measurement that we have. So in this case, it's 5.1 grams. And we multiply all that times 100 to get our percentage. So in this case, it's going to be 0.1. I'm just using my calculator. 0.1 divided by 5.1. I'm going to multiply that answer by 100, and I get 1.96%. Great. That's the percentage of uncertainty I have in this measurement right here. Now I'm going to do the same thing for this uncertainty in this measurement over here. So I'm going to take 0.01 milliliters, and I'm going to divide by 3.31 milliliters, and I'm going to multiply all that by 100, and I get, let's see what I get, 0.1 divided by 3.31 times 100, and I get 0.302, so 0.032%. So less than 1% uncertainty in this case, just over in this case. Now, the second step is to add these percentages. So I'm going to do that right now. I'm going to add these percentages. I'm going to use red to show that. Add the percentages. So when I add these percentages together, I'm going to take this number and this number, and I'm going to add them together. So I'm going to take 1.96 as a percent plus 0.302 as a percent. Add them together. Plus that. And I get as an answer 2.62%. Now, we haven't really covered rounding yet. So I'm going to leave it, I'm just going to round this to two figures here. So I'm going to say it's 2.3%. Okay? So that's what I'm going to have as my uncertainty. So my final answer, my very final answer, which I'm going to use this number up here, combined with this percentage right here, uncertainty, I'm going to say my final answer is 1.54 grams per milliliter plus or minus 2.3%. Okay? Now, we could figure out what 2.3% is out of this much grams per milliliter, but we're not going to do that. We don't need to do that for any of these problems. So just leave it as a percentage, and that's fine. All right? Okay, so hopefully that helps. If not, then email me.